Question 3a and b for waves. So the diagram shows a ripple tank. Here, remember, a ripple tank is, you should have seen this, it's one of your required practicals. It's just water, and there's a simple motor connected to a beam. The beam goes up and down and creates a regular wave going through the water. We sometimes shine a lamp through it, and what that allows us to do, sometimes the lamp might be shining up or down, it doesn't really matter which way. The key bit is we shine the light through and it creates shadows that we can then project onto something. We can measure the line, we can video, sometimes we can put a ruler down here. It's quite a nice way of doing it, put a ruler and video, take a photo. We can measure the distance between the lines, between the wavelengths. So each of these lines here represents the peak of a wave. Each of the dark lines. Okay, so what have we got? The motor makes a noise when it's turned on. Describe the differences between the properties of the sound waves produced, between the properties of the sound wave produced by the motor and the water waves. So we've got sound waves and water waves. It's worth 4 marks. So this is a describe the difference. This really is a compare question. It's going to be, there's an element of this is compare. So the first thing is we've got to describe the properties of the sound waves. Okay, so the most important property of sound waves is that they are longitudinal. So sound waves are longitudinal. Longitudinal. Okay, and we need to then state, so that's the information that we weren't given. We then need to make sure the examiner knows what that means. Longitudinal waves, longitudinal waves oscillate, let's vibrate, remember, oscillate in the same direction as the direction of energy transfer. Okay, remember, all waves transfer energy from one position, from the source to the destination, to the receiver. Okay, longitudinal waves oscillate in the same direction as direction of energy transfer. So when we talk about longitudinal, the way I always remember it is longitudinal starts with an L, and if I put arrows on both ends, there's only, the oscillations are always in the same direction, forwards or backwards, but in the same plane of direction. So up or down, or side to side, whichever way. So that's sound waves. The next one is water waves. Water waves are transverse. Okay, when I think about transverse waves, I think about T. The key bit here with the T is if I put arrows again, what I've got is I've got a right angle between 2 different directions. Okay, so water waves are transverse. Transverse waves oscillate at a right angle, or perpendicular to, at a right angle to the direction of energy transfer. And how we see that with the water waves is water waves go up and down, and yet the wave goes along, goes forwards through the water. So this question often comes up in exams, and one of the things they'll quite often do is they'll replace water waves for any of the EM waves. So by EM waves, remember, I mean the whole family of rich men in Vegas use X-ray glasses. So I mean radio, microwave, infrared, visible, ultraviolet, X-ray or gamma. They are all transverse waves. Sometimes sound, you might also be given ultrasound. So they like to compare ultrasound and X-rays. And as soon as they're doing that, what they're really saying is compare a longitudinal and a transverse wave. Okay, let's look at question 3, part B. So the period of the sound wave produced by the motor is 8.3 milliseconds. Calculate the frequency of the sound waves. Use the physics equation sheet. Okay, and the period is 8.3 milliseconds. So the first thing I do is I use every. I'll go to my equations, and if I find the correct equation for this, I would find so time period equals 1 divided by frequency. I'll spot this is worth 3 marks as well. So I've got the equation. The next thing I'm going to do is write down, I'll put this in a place where it won't get in the way, is write down the values. So I've got a line on the side here, and the only value I've got is I've got time period. So time period equals 8.3 milliseconds. Right, be really careful here. Milliseconds is an unusual unit for time, so we don't use it. Milli means divide by 1,000. So I'm going to replace it by that. So 8.3 divided by 1,000 seconds equals, let's just write that down properly, 8.3 divided by 1,000 equals 0.0083 seconds. That would be worth 1 mark right there. Okay, I'm then going to enter my values into the equation. So time period, sorry, got this in mind, 0.0083 equals 1 divided by f. I'm going to times both sides by f. I'm going to rearrange and solve it now. So I'm down to the r bit. Times both sides by f. 0.0083 times f is equal to 1. Then I'm going to divide both sides by 0.083 to make f the subject. 0.0083. So 1 divided by 0.0083 equals, so we can see equals 120.5 hertz. Now, I end up with quite a long number here. I don't write the whole number in. I also, because it's a long number, I check back here, does it say 2 SF anywhere? And if it did, obviously I'd convert that into 2 significant figures. Okay, hope that helps.